Hello dear students, welcome to the lecture 8 of Security of Information Systems. Today's topic is user authentication. Let's start with outline of this lecture.
Context of user authentication. Identity and authentication steps. User authentication. Knowledge-based authentication. Passwords. Ownership-based authentication. Tokens. Inherence-based authentication. Biometrics. Authentication frameworks for e-government. Taxonomy of authentication.
The authentication has two child nodes, which are entity authentication and data authentication. As an example for data authentication are MAC, digital signature, and PKA. We have seen them. And for entity authentication has three children, which are user authentication, organization authentication, and system authentication. For user authentication, we usually use passwords, tokens, OTP, and biometrics. For organization authentication, crypto protocols, e.g. like TSL, PKA are used. For system authentication, crypto protocols, e.g. IPsec and PKA is used.
Identity and access management (IAM) phases.
Configuration phase has three phases, which are registration of identity. First, you have to register the identity before you start authenticating it. Then provisioning of credentials.
Provisioning of credentials.
And then authorization of access. And operation phase has three phases, which are self-identification, claimed identity, authentication prove claimed identity, access control, and force access authorization policy.
Enforce access authorization policy.
In this lecture, we are going to see these two phases, provisioning of credentials and authentication.
User authentication credentials. A credential is the thing used for authentication. Credential categories. Knowledge-based, something you know, passwords. Ownership-based, something you have, tokens. Inherence-based, something you are, do, biometrics. Physiological biometric characteristics. Behavioral biometric characteristics. Combinations, called multi-factor authentication.
If you combine multiple of these credential categories, it is called as multi-factor authentication.
Knowledge-based authentication. Something you know, passwords.
This is the most common way of authentication, as we know.
Authentication, static passwords. Passwords are a simple and the most common authentication credential. Something the user knows.
So what problems there are for password authentication?
Easy to share intentionally or not.
Easy to forget. Often easy to guess, weak passwords. This is really a problem. And I think there have been several times the Twitter account of Trump has been hacked. Let me show you. news about this event. Okay.
Donald Trump's Twitter hacked after researcher guessed password. Donald Trump's Twitter account was allegedly hacked after a Dutch researcher correctly guessed the president's password, MAGA 2020, Dutch media reported. Security researcher and ethical hacker Victor Gevers could access to Trump's direct messages, post tweets in his name and change his profile, De Volkskrant newspaper reported. 4 years ago, Gevers, along 2 other Dutch ethical hackers, also hacked Trump's account. Gevers, who allegedly tried 4 times before using the correct password, says, "I expected to be blocked after 4 failed attempts. Or at least would be asked to provide additional information," Gevers told De Volkskrant. Gevers told De Volkskrant that President Trump was not using basic security measures such as multi-factor authentication. According to the news report, Gevers desperately reached out to Donald Trump to warn him, which turned out to be an impossible task.
Okay, so this can be true if you can guess the account password in few tries. You can actually log in that account. However, if you try multiple times, a good website would prevent you from further trying consecutively. This is actually what it says here. I expected to block it. Block it by who? Block it by Twitter in this case. Okay. So weak passwords are really a problem.
Can be written down, both good and bad. If written down, then what you know is where to find it. Often remains in computer memory and cache. RockU hack. 32 million cleartext passwords stolen from RockU database in 2009.
Okay, let's find some more information related to this event. Here, an article written 11 years ago.
Earlier today, news spread that social application site RockU had suffered a data breach that resulted in the exposure of over 32 million user accounts. To compound the severity of the security breach, it was found that RockU are storing all user account data in plain text in their database, exposing all that information to attackers. RockU have yet to inform users of the breach, and their blog is eerily silent, but the details of the security breach are going from bad to worse.
You see, they have stored passwords in plain text. Therefore, once hackers obtain an image of the database, they can basically log in every one of the user accounts. However, if they were hashed and even salted hashed, they couldn't guess the correct passwords if they were salted hashed. Okay. So if you use salted hashed password, even if your database get hacked, your account passwords would be still safe. Okay. Posted on the internet contains accounts and passwords for websites, MySpace, Yahoo, Hotmail, analyzed by Imperva.com. 1% of the users had used the extremely simple password here 1 2 3 4 5 6. 20% of the passwords were only 5 different passwords, therefore they are still very easy to crack. And so you see, with basically 25,000 tries you can get into one of the accounts. Okay, random account, any account actually.
Secure password strategies. Password's length 13 characters.
So you should have a password that is at least 13 characters. We can also test this. For example, and let's try a password like this. I will make it 13 characters, okay. Okay, so this is a pretty simple password. If it is 13 characters, it takes 14 days, okay. If it is 12 characters, it takes 3 days. And this is still very simple password. We should also use uppercase, lowercase. I'm going to add uppercase and lowercase to my password like this. For example, I have added a lowercase. Now it is it's still 14 days, and then I'm going to add an uppercase like this. Let's try it out. Still 13 characters. Okay, it takes 29 days to crack, and then it says I should also add special characters such as I'm going to add a dollar sign into my password, and let's try this. Okay, now it takes 1700 years. I mean 1700 years. Okay, so this is practically impossible password to crack at the moment. You see how using combination of different characters improves your password security.
Do not use ordinary words, names, dictionary WDS.
Dictionary words.
Change typically every 3-13 months. OK to reuse between low sensitivity accounts.
Okay, this reuse means that let's say you are registering different e-commerce websites and you are using the same password. So if one of them gets hacked, the hackers can access your other e-commerce website accounts as well by using the same password. Therefore, you should use different passwords for each sensitive website. Okay. However, let's say you are registering to random forums which are not important at all. You may use the same password because if your account gets hacked, you wouldn't lose anything, or you are registering to spam websites and such. So this is really important to use different passwords.
Do not reuse between high sensitivity accounts. Store passwords securely.
Okay, in brain memory means that keep it in your memory. Do not save it anywhere else. Okay, on paper, adequately protected. So if you store your password physically, it can only be stolen by a real burglar. That would be have to get into your house and steal your paper, which is much harder than digital hacking.
In clear text on offline digital device, adequately protected.
This is also a possible way. Let's say you are keeping it in a USB flash memory, which is not connected to your computer.
Encrypted on online digital device.
If you encrypt your password with another password that you would keep in your brain memory, it would be still pretty secure.
Strategies for strong passwords. User education and policies. Not necessarily with strict enforcement.
User education is really important. People need to understand the importance of secure passwords. Okay.
Proactive password checking. User selects a potential password which is tested. Weak passwords are not accepted.
Usually, now these websites do not accept your simple passwords. Okay, they forces you to pick a stronger password for registration or changing your password, updating your password.
Reactive password checking. Sysadmin periodically runs password cracking tool, also used by attackers, to detect weak passwords that must be replaced. Computer-generated passwords. Random passwords are strong but difficult to remember. FIPS Pub 181 http://www.itl.nist.gov/fipspub/fip 181.htm specifies automated pronounceable password generator.
Okay, let's check this out and see how it is work. Okay, looks like that page is remote, and maybe you can look for it on the internet. Okay, there are the PDF files related to this. Okay, alternatively, you can use the password manager of Chrome, for example. Okay, what I mean is, let me show you. Okay, it goes to Turkish page, but let's change it to global website. And here, let's click start. And I just want to find the registry page of Kaspersky. Or let's use another website. Let's register Twitter. It doesn't matter because whatever we use as an example. Okay, here okay, it also okay, here it's the Chrome suggests me a strong password like this. You see, this password would take forever to crack. Let me show you what I mean. This is an automated generated password. It will be saved in my Google account, which I have logged in my Chrome browser. And let's see how much time it takes. This takes 3,261 centuries. Okay, so it is impossible to crack at all these passwords. Okay. Okay. Okay.
Password storage in OS.
OS is operating system. Operating system. Okay.
Etc. Shadow is the file where modern Unix stores its passwords. Earlier version stored it in etc. passwd. Need root access to modify it. Windows System 32 config SAM is the file Windows system normally stores its passwords. Undocumented binary format. Need to be administrator to access it. Network environments store passwords centrally. AD Active Directory on Windows servers. LDAP Lightweight Directory Access Protocol on Linux. Prevent exposure of password file. Systems verify user passwords against stored values in the password file. Password file must be available to OS. This file need protection from users and applications. Avoid offline dictionary attacks. Protection measures. Access control only accessible by root admin. Hashing or encryption. In case a password file gets stolen, then hashing, encryption provides a level of protection.
Yes, you should use salted hashes to have maximum available protection.
Hash functions. One-way function.
Any size input and it produces a fixed size hash, easy computation, and it is almost impossible. Actually, it is impossible to inverse. What can be done? What can be done is doing a brute force to check against all string combinations and try to find the same hash.
Collision free.
If you use two-way password, by the way, this is the collision-free hashes.
Difficult to find different input values producing same hash.
So your hash function should be collision-free. It should be extremely hard to find different value that will produce the same hash. Okay.
A hash function is easy to compute but hard to invert.
What is hashing collision? Let's get an idea about it. I think we have explained it already, but let's review it again.
In computer science, a collision or clash is a situation that occurs when two distinct pieces of data have the same hash value, checksum, fingerprint, or cryptographic digest. 1. Due to the possible applications of hash functions in data management and computer security, in particular, cryptographic hash functions, collision avoidance has become a fundamental topic in computer science. Collisions are unavoidable whenever members of a very large set, such as all possible person names, or all possible computer files, are mapped to a relatively short bit string. This is merely an instance of the pigeonhole principle. 1.
So what is pigeonhole principle?
In mathematics, the pigeonhole principle states that if n items are put into m containers with n greater than m, then at least one container must contain more than one item. 1. For example, if you have 3 gloves, then you must have at least 2 right-hand gloves, or at least 2 left-hand gloves, because you have 3 objects, but only 2 categories of handedness to put them into. This seemingly obvious statement, a type of counting argument, can be used to demonstrate possibly unexpected results. For example, if you know that the population of London is greater than the maximum number of hairs that can be present on a human's head, then the pigeonhole principle requires that there must be at least 2 people in London who have the same number of hairs on their heads.
Okay, it's a simple principle.
The impact of collisions depends on the application. When hash functions and fingerprints are used to identify similar data, such as homologous DNA sequences or similar audio files, the functions are designed so as to maximize the probability of collision between distinct but similar data, using techniques like locality-sensitive hashing. 2. Checksums, on the other hand, are designed to minimize the probability of collisions between similar inputs, without regard for collisions between very different inputs. 3.
So in computer security, let's read about that.
Hash functions can map different data to the same hash. By virtue of the pigeonhole principle, malicious users can take advantage of this to mimic data. For example, consider a hash function that hashes data by returning the first 3 characters of the string it is given, i.e., password 12345 goes to PA. A hacker, who does not know the user's password, could instead enter pass, which would generate the same hash value of PA. Even though the hacker does not know the correct password, they do have a password that gives them the same hash, which would give them access. This type of attack is called a pre-image attack. In practice, security-related applications use cryptographic hash algorithms, which are designed to be long enough for random matches to be unlikely, fast enough that they can be used anywhere, and safe enough that it would be extremely hard to find collisions. 3.
Okay, there is collision attack. Let's learn about that as well.
In cryptography, a collision attack on a cryptographic hash tries to find 2 inputs producing the same hash value, i.e. a hash collision. This is in contrast to a pre-image attack where a specific target hash value is specified. There are roughly 2 types of collision attacks. Collision attack find 2 different messages M1 and M2 such that hash M1 equals hash M2. More generally, chosen prefix collision attack given 2 different prefixes P1 and P2, find 2 appendages M1 and M2 such that hash P1M1 equals hash P2M2, where denotes the concatenation operation.
Okay.
Much like symmetric key ciphers are vulnerable to brute force attacks, every cryptographic hash function is inherently vulnerable to collisions using a birthday attack. Due to the birthday problem, these attacks are much faster than a brute force would be. A hash of n bits can be broken in 2n, 2-time, evaluations of the hash function.
So what is birthday attack?
A birthday attack is a type of cryptographic attack that exploits the mathematics behind the birthday problem in probability theory. This attack can be used to abuse communication between 2 or more parties. The attack depends on the higher likelihood of collisions found between random attack attempts and a fixed degree of permutations pigeonholes. With a birthday attack, it is possible to find a collision of a hash function in text style sqrt 2*n equals 2*n2, with text style 2*n being the classical pre-image resistance security. There is a general, though disputed, result that quantum computers can perform birthday attacks, thus breaking collision resistance, in text style sqrt 3 2*n equals 2*n3 2. As an example, consider the scenario in which a teacher with a class of 30 students n equals 30 asks for everybody's birthday. For simplicity, ignore leap years to determine whether any 2 students have the same birthday, corresponding to a hash collision as described further. Intuitively, this chance may seem small. If the teacher picked a specific day, say, the 16th of September, then the chance that at least one student was born on that specific day is \1 364 365 30, about 7.9%. However, counterintuitively, the probability that at least one student has the same birthday as any other student on any day is around 70% for n equals 30, from the formula \1 frac 365 365n cdot 365 n 3.
Okay, so with 16 bits, possible outputs are 2 over 2 power 16. This is equal to about this 65k. And desired probability of random collision is shown like this. And if you use 512 bits, you see it gets something like this, and the collision probably becomes impossible. Okay, this is a good example.
Table shows number of hashes n, p, needed to achieve the given probability of success, assuming all hashes are equally likely. For comparison, 10-18 to 10-15 is the uncorrectable bit error rate of a typical hard disk. 7, in theory, MD5 hashes or UUIDs, being 128 bits, should stay within that range until about 820 billion documents, even if its possible outputs are many more.
So if you get 820 billion documents, if you generate, they would start colliding in the hard disk or hard drive. So if they are being kept with MD5 hashes, you will start getting collisions. Therefore, you couldn't generate that many documents in your hard drive. Okay, so hashes can be used to index the elements, or they can be used for security purposes as well. So it is about how much possibility, how many possible solutions there are. Okay. All right, and okay, let's continue.
Passwords can be stored as hash values. Authentication function first computes hash of received password, then compares against stored hash value.
So the authentication function, what does it do? It is so simple. Let me explain it. And you should also follow the same approach. So I will just write a simple application. Okay, we don't need using SQL right now. Okay, what I'm going to do is, let's say you register a person and check the login. Okay, so I will just use this method. Okay. Okay, looks like I have an error in my application. So let's just compose another project. Okay. Maybe the name was too long. Okay, let's change it. I will compose .NET Core because it would also work. It's working. So let's copy and paste our compute hash. I'm going to make this an exact extension. So then to save that user password, what I am going to use is simply I'm just trying to show you the primary concept of password hashing. Okay, so in my application at somewhere I am keeping a let's say my salt. Okay, so when I run this application, oh, looks like we are having a path problem. Okay, this is really unexpected. So let's compose another project. Yeah, probably due to this. Okay. This will reduce my file path length. When your file path is too long, it may cause your application to not work as expected. I hope this time it will work. Okay, it looks like working. Not. Okay. Okay, yes. So the path is now shorter. Let's copy and paste this. And okay, here. Okay, it says okay, I understand that. I'm going to add a class and call it as extensions. Okay, I'm going to add that extension to here. like this. With this way, now I can directly use, oh, I don't even need this because it's an extension. Sorry about that. Okay, we get the user password as raw. Then we will compose our salted hash. To do that, I'm going to add here, or let's add it to our software like this. By the way, whatever you put in your application, that can be reversed back. So your authentication has to be on your server, and you have to authenticate users by a web service, web API. If you directly distribute your exe, hackers can read everything embedded into your exe, including your password salt. The salt, uh, therefore, your um, authentication system has to be on a server where users cannot directly access, and by a web service API you have to authenticate users. Okay. So I am just showing you the basic idea here. So my password salt is, let's say uh, systems, and I'm going to read my salt here. Okay, txt. Okay, and I will copy this into the debug folder. And then what we are going to do is write another extension method here. Okay, let's add this. What this is going to return is, I'm going to add it to here, and this will return um, as this. So I will append this hash, this salt, to every password before I save it, and cool too. Hashed password. I will take a pause for a moment. Okay, so first we generate salted hash of the password, then we save it to our database For as an example, I will save it to a file. Then I will request user to enter password for login. Okay. This is the basic idea what you have to do in your web service, web application. Okay. Okay, and so we will get the password of user for login. Then we will check whether the user entered password is same to the saved password or not as hash. I will make it as infinite loop. This is for just demonstration purposes, and you see here I am going to compare the new password hashed form with the saved hashed password. And then I will read another key for continue. Okay, so let's say our password as security. Okay, so I'm typing my password as security. Then it is asking me to my password to login. I will type security, but the I at the end will be bigger. So you see, your entered password is security. The salted hash of your password is this one. However, the saved password is this one. You see how much it is different? It is completely different with just one character being different. So it says login failed, and I will continue. This time I will add a space character to the end like this, and I will click enter. So you see it is completely different again. This is how salt hashing works. Okay, and with salted hashing I am preventing rainbow tables as well. And if you remember rainbow tables, they were pre-computed hashes of common passwords to check against them. And if you use a salted hash, it would be even more secure. So let's enter our password like this. So you see now it is working as expected because their hashes are matching. So what you need to do is save user passwords as hashes, and when user tries to log in, compare hashes. Okay, this is how you need to handle user passwords. Okay, so let's continue. I'm going to remove this project, by the way. So it was okay, it was here. Yeah, I'm going to remove this. Okay, we can continue to our slide.
Cracking passwords.
By the way, this is brute force. Okay, so the first method is brute force, trying all combinations.
Trying all possible combinations. Intelligent search. Username.
Name of friends, relatives, phone number, birthdays, dictionary attack, which is a pretty common way, or passwords from other websites, hacked websites. This can be also counted as dictionary attack.
Try all words from a dictionary. Pre-computed hashes, rainbow tables.
You see, when you use salted hash, rainbow tables becomes unusable. Okay, they becomes useless.
Hash table and rainbow table attacks. Attackers can compute and store hash values for all possible passwords up to a certain length. A list of password hashes is a hash table. A compressed hash table is a rainbow table. Comparing and finding matches between hashed passwords and hash rainbow table is the method to determine cleartext passwords. Password salting, defense against password cracking. Prepend or append random data salt to a user's password before hashing.
We did a prepend on our application here. So we add the salt to the front of the password. Okay, before we calculate the hash.
In Unix, a randomly chosen integer from 0 to 4095. Different salt for each user. Produces different hashes for equal passwords. Prevents that users with identical passwords get the same password hash value.
So you can use random hash, random salt, and keep that in your database. Even if your database would get hacked, practically all of the rainbow tables would be useless. Okay, because they would have to recompute all of the combinations of passwords with that particular rainbow, with that particular salt. Okay. However, since you know the salt yourself, you can your system would work as expected.
Increases the amount of work required for hash table attacks and rainbow table attacks. Storing and checking passwords.
So my pass clear text, and if you save the clear text as clear text, the password as a clear text, it is bad security. Okay, because once your database gets hacked, they can access all of the users' profiles, and even if you fix the hacking, even if you patch the vulnerabilities, the hackers would have password of all users. So if you just hash simply, It is moderate security, hashed password database like this. However, if you use salted hashed password, it's a good security and the attackers can't do anything. Okay, even if they have obtained all of the salted hashes.
Problems with using passwords in the clear. A password sent in clear can be captured during transmission, so an attacker may reuse it. An attacker setting up a fake server can get the password from the user, e.g. phishing attack. Solutions to these problems include encrypted communication channel, one-time passwords, token-based authentication, challenge response protocols.
So to prevent phishing attack, you need to use one-time passwords. So with that way, user wouldn't enter her password. The user would expect tokens to be generated.
HTTP digest authentication. A simple challenge response protocol rarely used. A simple challenge response protocol specified in RFC 2069. Server sends www authenticate equals digest. Realm equals service domain. Nonce equals some random number. User types ID and password in browser window. Browser produces a password digest from nonce, ID and password using a one-way hash function. Browser sends ID and digest to server that validates digest.
Okay, so let's find some more information relating to these methods.
Digest access authentication is one of the agreed-upon methods a web server can use to negotiate credentials, such as username or password, with a user's web browser. This can be used to confirm the identity of a user before sending sensitive information, such as online banking transaction history. It applies a hash function to the username and password before sending them over the network. In contrast, basic access authentication uses the easily reversible base 64 encoding instead of hashing, making it non-secure unless used in conjunction with TLS. Technically, digest authentication is an application of MD5 cryptographic hashing with usage of nonce values to prevent replay attacks. It uses the HTTP protocol.
If you use HTTPS protocol, you don't need this because your communication will be already encrypted and it is better actually. Okay, so this is an old methodology, I would say. Okay, let's continue.
Ownership-based authentication. Something you have, tokens.
Okay, so authentication tokens are synchronized tokens, challenge response tokens, clock-based tokens, and counter-based tokens.
Synchronized OTP, one-time password generator. Using a password only once significantly strengthens the strength of user authentication. Synchronized password generators produce the same sequence of random passwords both in the token and at the host system. OTP is something you have because generated by token.
So OTP is one-time password.
There are two general methods: clock-based tokens, counter-based tokens. Clock-based OTP tokens, operation. Token displays time-dependent code on display. User copies code from token to terminal to log in. Possession of the token is necessary to know the correct value for the current time. Each code computed for specific time window. Odes from adjacent time windows are accepted. Clocks must be synchronized. Example, bank ID and Securit. Clock-based OTP token operation with optional input pin.
So user's token based on clock, user ID, secret key, algorithm, and pin. OTP, and on the host, clock, algorithm, user ID, secret key, and optional pin, OTP, and they compare each one. Okay. So the user doesn't enter their secret key, but they still have to enter their pin.
Clock-based OTP tokens. Safe ID OTP token with pin.
Okay, let's check this out.
This video provides instructions for resetting the PinPad PIN code. PIN entry UK. Incorrect unlock codes. The PUC code being entered here.
Let's look how to use them in our real-life applications.
This video will be logging in to Office scripts of second factor and verification code from mobile applications. Navigate to the Office 365 login page at the following web address. If you've selected a must be entered into the login window. Login. Click on the prompt, sign in another way.
This doesn't explain. Oh, use a verification code for my mobile app. Actually, this is what it should be.
To use the Safe ID hardware token, you need to select the verification code from mobile app method.
Okay, this is a common way of authentication. You install an app to your phone, and it generates a one-time token, and your remote server, your remote software asks that token. Okay, this is what it is.
Hacking OTP tokens. RSA was hacked in 2007. Secret key for OTP tokens stolen. Hackers could generate OTP and spoof users. Companies using RSA Secure ID were vulnerable. Lockheed Martin used RSA Secure ID. Chinese attackers spoofed Lockheed Martin staff. Stole plans for F-35 fighter jet. Counter-based OTP tokens, overview. Counter-based tokens generate a password result value as a function of an internal counter and other internal data, without external inputs. HOTP is a HMAC-based one-time password algorithm described in RFC 4226, December 2005.
Okay, you can read all details about this on here. It is 35 pages anyway.
Tokens that do not support any numeric input. The value displayed on the token is designed to be easily read and entered by the user. Counter-based OTP token operation.
I don't know if this is being
Counter-based
used.
OTP.
I don't know if this is being used anywhere. Okay. Oh, I see.
HOTP, Event-Based One-Time Password. Event-Based OTP, also called HOTP meaning HMAC-Based One-Time Password, is the original one-time password algorithm and relies on two pieces of information. The first is the secret key, called the seed, which is known only by the token and the server that validates submitted OTP codes. The second piece of information is the moving factor which, in event-based OTP, is a counter. The counter is stored in the token and on the server. The counter in the token increments when the button on the token is pressed, while the counter on the server is incremented only when an OTP is successfully validated. To calculate an OTP, the token feeds the counter into the HMAC algorithm using the token seed as the key. HOTP uses the SHA-1 hash function in the HMAC. This produces a 160-bit value which is then reduced down to the 6 or 8 decimal digits displayed by the token. TOTP, Time-Based One-Time Password. Time-based OTP, TOTP for short, is based on HOTP but where the moving factor is time instead of the counter. TOTP uses time in increments called the time step, which is usually 30 or 60 seconds. This means that each OTP is valid for the duration of the time step. Comparison. Both OTP schemes offer single-use codes, but the key difference is that in HOTP a given OTP is valid until it is used, or until a subsequent OTP is used. In HOTP there are a number of valid next OTP codes. This is because the button on the token can be pressed, thus incrementing the counter on the token, without the resulting OTP being submitted to the validating server. For this reason, HOTP validating servers accept a range of OTPs. Specifically, they will accept an OTP that is generated by a counter that is within a set number of increments from the previous counter value stored on the server. This range is referred to as the validation window. If the token counter is outside of the range allowed by the server, the validation fails and the token must be resynchronized. So clearly in HOTP there is a trade-off to make. The larger the validation window, the less likely the chance of needing to re-sync the token with the server, which is inconvenient for the user. Importantly though, the larger the window, the greater the chance of an adversary guessing one of the accepted OTPs through a brute force attack. In contrast, in TOTP there is only one valid OTP at any given time, the one generated from the current Unix time.
Okay, so basically you get a device and you synchronize it with the server. Then by using that device you can generate a token with synchronization of the remote server, and by using that token you can log into your application, server, website, whatever you are using. Okay, this is the basic idea.
Challenge response-based tokens for user authentication. A challenge is sent in response to access request. A legitimate user can respond to the challenge by performing a task which requires use of information only available to the user and possibly the host. User sends the response to the host. Access is approved if response is as expected by host. Advantage: since the challenge will be different each time, the response will be too, the dialogue cannot be captured and used at a later time. Could use symmetric or asymmetric crypto. Token-based user authentication challenge response systems.
So for token, it uses ID key encrypt optional display, and response is sent, and IDK encrypted with random number generator and challenge. Interesting. Let's find some example.
In computer security, challenge response authentication is a family of protocols in which one party presents a question challenge and another party must provide a valid answer response to be authenticated. The simplest example of a challenge response protocol is password authentication, where the challenge is asking for the password and the valid response is the correct password.
Okay, so this is what it is.
Clearly, an adversary who can eavesdrop on a password authentication can then authenticate itself in the same way. One solution is to issue multiple passwords, each of them marked with an identifier. The verifier can ask for any of the passwords, and the prover must have that correct password for that identifier. Assuming that the passwords are chosen independently, an adversary who intercepts one challenge response message pair has no clues to help with a different challenge at a different time. For example, when other communications security methods are unavailable, the U.S. military uses the AKAC 1553 triad numeral cipher to authenticate and encrypt some communications. Triad includes a list of 3-letter challenge codes, which the verifier is supposed to choose randomly from, and random 3-letter responses to them. For added security, each set of codes is only valid for a particular time period, which is ordinarily 24 hours. A more interesting challenge response technique works as follows. Say, Bob is controlling access to some resource. Alice comes along seeking entry. Bob issues a challenge, perhaps 52W72Y. Alice must respond with the one string of characters which fits the challenge Bob issued. The fit is determined by an algorithm known to Bob and Alice. The correct response might be as simple as 63x83z, each character of response one more than that of challenge, but in the real world, the rules would be much more complex. Bob issues a different challenge each time, and thus knowing a previous correct response, even if it is not hidden by the means of communication used between Alice and Bob, is of no use.
Okay, now we get the idea. I will take a pause. Okay, all right.
Token-based user authentication challenge response systems.
Okay, the token is generated by ID key encrypt optional display, sent as a response. Okay.
Contactless cards, overview. Contactless cards, also called RFID, radio frequency ID cards, consists of a chip and an antenna. No need to be in physical contact with the reader. Uses radio signals to communicate. Powered by magnetic field from reader. When not within the range of a reader, it is not powered and remains inactive. Battery-powered RFID tags also exist. Suitable for use in hot, dirty, damp, cold, foggy environments. Inherence-based authentication. Biometrics. Something you are. Something you do. Biometrics, overview.
Okay, what is it? Let's read it.
Automated methods of verifying or recognizing a person based upon a physiological characteristics. Biometric modalities, examples. Fingerprint, facial recognition, eye retina, iris scanning, hand geometry, written signature, voice print, keystroke dynamics.
I would say every one of these can be easily tricked if wanted. So I wouldn't say these are as strong as a strong password with a salted hashing methodology.
Biometrics, requirements. Universality, each person should have the characteristic. Distinctiveness, any two persons should be sufficiently different in terms of the characteristic. Permanence, the characteristic should be sufficiently invariant with respect to the matching criterion over a period of time. Collectability, the characteristic should be measurable quantitatively. Biometrics, practical considerations. Accuracy, the correctness of a biometric system, expressed as error equal error rate, where a low error is desirable. Performance, the achievable speed of analysis, the resources required to achieve the desired speed. Acceptability, the extent to which people are willing to accept the use of a particular biometric identifier, characteristic. Circumvention resistance, the difficulty of fooling the biometric system.
For example, I think it is pretty easy to fool both voice and retina scan. Okay, because from high resolution pictures, they are able to fool the retina scan, and with recent machine learning algorithms, it is much easier to mimic the voice of a person. And probably others are also like that. I wouldn't trust any of these for my critical systems.
Safety, whether the biometric system is safe to use. Biometric safety. Biometric authentication can be safety risk. Attackers might want to steal body parts. Subjects can be put under duress to produce biometric authenticator. Necessary to consider the physical environment where biometric authentication takes place. Car thieves chopped off part of the driver's left index finger to start S-Class Mercedes-Benz equipped with fingerprint key. Malaysia, March 2005. NST picture by Mode Said Samad.
As you can see, it is much easier to bypass these systems. However, if it was 15 character length password with a salted hash, it would be impossible to crack. or such.
Biometrics, modes of operation. Enrollment, analog capture of the user's biometric attribute. Processing of this captured data to develop a template of the user's attribute which is stored for later use. Identification, one-to-many, capture of a new biometric sample. Search the database of stored templates for a match based solely on the biometric. Verification of claimed identity, one-to-one, capture of a new biometric sample. Comparison of the new sample with that of the user's stored template. Extracting biometric features, example fingerprints, extracting minutia.
Okay, biometric reading, minutia points here, minutia map and data stream. So you compare this data stream when you read the fingerprint again, okay.
Biometrics, system components.
Of course, there are sensors to get the biometric data, feature extractor. From that raw data, you extract the features and matcher. With the matcher function, you compare the extracted features with that moment and with the saved ones in the database, and if they are matching, the authentication is successful.
Biometrics, enrollment.
Name, pin, user return, quality checker, feature extractor, system database template. Okay. Biometrics verification.
Biometrics, verification.
Feature extractor, matcher, one match, true, false, one template, system database, claimed identity.
Biometrics, identification.
Feature extractor, matcher and matchers, user's identity or user identified, and templates, system database. Okay.
Evaluating biometrics. Features from captured sample are compared against those of the stored template sample. Score S is derived from the comparison. Better match leads to higher score. The system decision is tuned by threshold T. System gives a match same person when the sample comparison generates a score S where S is greater than or equal to T. System gives non-match different person when the sample comparison generates a score S where S less than T. Matching algorithm characteristics. True positive, user's sample matches right pointing arrow user is accepted. True negative, stranger's sample does not match right pointing arrow stranger is rejected. False positives, stranger's sample matches right pointing arrow stranger is accepted. False negatives, user's sample does not match right pointing arrow user is rejected. False match rate and false non-match rate FMR equals hash matching stranger samples, total hash stranger samples FNMR equals hash non-matching user samples, total hash user samples. T determines trade-off between FMR and FNMR.
Okay.
Evaluating biometrics, system errors. Comparing biometric samples produces score S. Acceptance threshold T determines FMR and FNMR. If T is set low to make the system more tolerant to input variations and noise, then FMR increases. On the other hand, if T is set high to make the system more secure, then FNMR increases accordingly. EER equal error rate is the rate when FMR equals FNMR. Low EER is good.
Okay.
Spoofing biometrics, presentation attacks. It is relatively simple to trick a biometric system. Terminology, presentation attacks.
False finger like here or false face like here.
Biometric authentication on smartphones is insecure. Pad presentation attack detection is the subject of intensive research to make biometrics more secure. Alternative solution is to capture biometrics in controlled environments.
Yes. Okay.
Authentication, multi-factor. Multi-factor authentication aims to combine two or more authentication techniques in order to provide stronger authentication assurance. Two-factor authentication is typically based on something a user knows, factor 1, plus something the user has, factor 2. Usually this involves combining the use of a password and a token, example, bank ID OTP token with PIN plus static password.
The most common usage of multi-factor authentication in nowadays is password plus an SMS that is sent to your phone. So if you enable two-factor authentication, you will need to know the password and have the phone itself to authenticate. This is extremely secure because it is very hard for hackers to obtain both your phone and your password. Therefore, multi-factor authentication is really important, useful, and secure. Okay.
Authentication assurance. Authentication assurance equals robustness of authentication. Resources have different sensitivity levels. High sensitivity gives high risk in case of authentication failure. Authentication has a cost. Unnecessary authentication assurance is a waste of money. Authentication assurance should balance resource sensitivity. Required user authentication assurance level. Authentication risk. E-authentication frameworks for eGov. Trust in identity is a requirement for e-government. Authentication assurance produces identity trust. Authentication depends on technology, policy, standards, practice, awareness, and regulation. Consistent frameworks allow cross-national and cross-organizational schemes that enable convenience, efficiency, and cost savings. Alignment of e-authentication frameworks. AAL, Authentication Assurance Level. AAL is determined by the weakest of three links.
Okay, so what may they be?
User Identity Registration Assurance (UIRA) requirement. User Credential Management Assurance (UCMA) requirements. User Authentication Method Strength (UAMS) requirements. Requirements for correct registration, pre-authentication credentials, e.g. birth certificate, biometrics. Requirements for secure handling of credentials, creation, distribution, storage. Requirements for mechanism strength, password length and quality, cryptographic algorithm strength, tamper resistance of token, multiple factor methods. AIDA's electronic identification, authentication and trust services. AIDAS is EU's regulation on e-authentication and trust services for e-transactions. Trust service is EU jargon for PKI certification services. AIDAS specifies three authentication assurance levels (AALs). The EU Trust Mark for qualified trust services. Low Assurance EDAS AAL1 Substantial Assurance AIDAS AAL2 High Assurance AIDAS AAL3 Limited degree of confidence in the claimed or asserted identity of a person.
Okay, let's read this again. more properly.
Low assurance EDASAAL1. Limited degree of confidence in the claimed or asserted identity of a person. Substantial assurance ADAS-AAL2. Substantial degree of confidence in the claimed or asserted identity of a person. High assurance ADAS-AAL3. Higher degree of confidence in the claimed or asserted identity of a person. Risk analysis for e-authentication. Determining the appropriate AAL for an application.
Okay, impact of A authentication failure. If it is minor and required ALL is low, if it is moderate, substantial, and if it is major, high.
E-authentication failure means that an imposter is able to attack and steal somebody else's identity. Rau Norway 2008 54 Rammeverk for Autentisering og uavhengighet framework for authentication and non-repudiation. Rau AAL4, high authentication assurance, e.g. two-factor, where at least one must be dynamic, and at least one is provisioned in person. Rau AAL3, moderate authentication assurance, e.g. OTP calculator with PIN provisioned by mail to user's official address. Rau AAL2, low authentication assurance, e.g. fixed password provisioned in person or by mail to user's official address. Rau AAL1, little or no authentication assurance, e.g. online self-registration and self-chosen password.
Okay, so you see the lowest security is online self-registration and self-chosen password. Okay, and the one upper level is fixed password sent to the person by mail, by a physical mail to your official address. One higher method is OTP calculator with PIN provisioned by mail. So they are sending you an OTP device physically to your address, and the best one is like your phone registered to the system by officials and your static password sent to you physically. Okay, so this is like multi-factor authentication with phone verification and a fixed password or hidden password, something like that.
Norway will adopt ADAS in 2018. Rau will no longer be used.
So Norway is going to ADAS. I wonder if Turkey is also on ADAS. Yeah, looks like we are also on ADAS. Yeah, looks like we are also on ADAS. And let's get some more idea related to ADAS.
ADAS, Electronic Identification, Authentication and Trust Services, is an EU regulation on electronic identification and trust services for electronic transactions in the European single market. It was established in EU Regulation 910/2014 of the 23rd of July 2014 on electronic identification and repeals Directive 1999/93 EC from the 13th of December 1999. 1-2. It entered into force on the 17th of September 2014 and applies from the 1st of July 2016 except for certain articles, which are listed in its Article 52. 3. All organizations delivering public digital services in an EU member state must recognize electronic identification from all EU member states from September 29, 2018. 4.5.
Okay.
Only 3 AALs in modern eAuth frameworks. Early e-authentication frameworks typically had 4 AALs. In practice, the very low AAL is not used. Very low AAL is inadequate for cross-border, federated auth. ADAS assumes cross-border authentication. NIST SP 800-633 assumes federated authentication. Current providers of highest AAL, RAW AAL4 in Norway. Comfides, Bypass, Bank ID, PA Mobile. Adoption of ADAS in Norway will probably be relatively simple. Some authentication service providers may need to make changes to keep accreditation for the highest AAL, EIDAS AAL3.
Okay, end of lecture. So if you have any questions, you can ask me by our Discord channel or by my email. Please also start working on your project. By the way, at the end, with your project delivery, I will also take a Word from a PDF or Word file from you, which will show screenshots of your comments to each lecture. Okay, you know our commenting system to lecture videos, and we are looking for volunteers our subtitle project as well. And let's see what is the status. Okay, so you see we are awaiting more people for volunteering. Okay, we are really behind. Okay, hopefully see you next week. Please stay away from coronavirus. My grandfather has passed away from coronavirus recently. So it is a really serious disease. I think you already know it. By the way, before ending the video, so in this exe file, whatever I put my exe can be read by third-party software, even if you use code obfuscation. Okay, okay, it's already appeared. So even if you use code obfuscation, they can be still decrypted. Therefore, never trust anything you put into your client software. Okay, client software can always be hacked, decrypted, mapped. Therefore, for security requiring systems, for let's say critical systems, you have to use a remote server. Where will the authentication be happen? Where will the data will be stored? Because there will be because the users will be able to communicate with the remote server only by the interface that you have coded, such as web API or web applications and such. And always remember that. Okay, end of lecture.